Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz. I'm glad you've taken the time to join us today as we look at our topic of how to select a clean room or ESD torque screwdriver. Now, when we talk a lot during our webinars, we usually mention right at the beginning our fastening risks that go along with the torquing applications. And if we want to try and mitigate some of those, if we understand what those are, it helps us to be able to do that. And so obviously, we're dealing with torque products, and we want to make sure that our torque is correct. We don't want anything that's going to be over-torqued. Over-torque can certainly lead to damage and breakage due to the fact that we may stretch the fastener past its yield point and move it into the plastic region for that fastener. We want to make sure that we're staying within the elastic region of a particular fastener for a particular application. And conversely, under-torquing is also extremely bad. If there is any type of vibration that may happen that can cause that fastener to completely fail, then we have parts moving that are designed not to be moving, and that can obviously cause failure there as well. Excuse me. Now, some of the other fastening risks that we deal with primarily can do with either fasteners that aren't fully seated. Again, this would be an under torque type of situation where the operator doesn't fully seat the fastener. And the operator themselves can be one of the biggest causes to fastening errors that we may see. So if an operator understands primarily what's happening, their role, and making sure that they're doing their fastening complete, this can certainly help in mitigating some of those fastening risks that go along with torque control and trying to achieve the very best for our applications. Now, when we're talking about torque control, what we're really trying to achieve is getting the correct clamp load on our part. And by getting the correct torque, we are making sure that we're stretching that fastener to the right amount to create the clamp force for the pieces or parts to stick together. And so if we have any variation in that clamp load, that's where we can see failures. And we want to make sure that with the proper torque control, this is going to help in creating very reliable processes that we'll be going through to help us reduce any type of scrap rate. We don't want parts that are being not torqued correctly to be scrapped, and we want to make sure that we're meeting the quality standards for a particular application as it relates to the actual process that we're doing. And all of this helps to safeguard against failure for the actual torquing applications. Now, the manufacturing environmental demands that can be placed on a certain type of application is kind of what we're talking about today. And that's going to be with the use of either a clean room environment or an ESD environment. And obviously in a clean room environment, we want to help to try to control any type of dust particles or microbes, any volatile organic compounds that might be there, other pollutants. So that is what we're trying to mitigate through that. The ESD, we'll touch on that a little bit more as we get on that, but that's electrostatic discharge, and we're trying to help mitigate that as well. And so when we talk about these two different types of environments, that's going to lead us to basically our poll question for today. And if we want to go ahead and launch that poll, we're asking basically what environmental demands impact tooling requirements in your manufacturing process. And we have clean room requirements, preventing ESD, any type of FOD or foreign objects, all of the above or none of the above. So I'll give you a second here to go ahead and answer that question, and we'll then All right. Looking at our poll here, the overwhelming response is the all of the above. So that is fantastic news for today, and what we are looking at in some of our process here for our ESD and clean room type of tools. And so there are a lot of torque limiting technologies that are clean room and ESD available in a electric style torque screwdriver, and those can be used in different requirements for those different applications. But obviously today we're talking about hand torque screwdrivers, and the quality standards that go around those particular tools fall under the ISO 6789 regulation, which is that those tools must reach 5,000 cycles and stay within a plus or minus 6% of the setting. And so our FG screwdrivers, along with our FG clean room and our FG ESD, meet those requirements fully to those ISO 6789 standards. And this also is applicable for some other types of torque wrenches. But once we get past a certain range, 10 newton meters, then that value decreases down to plus or minus 4%. But all of our torque screwdrivers all fall within the plus or minus 6%, with those standards holding their calibration for 5,000 cycles. And so when we look at specific tools and how they accomplish providing torque to an application, there are some differences between the different manufacturers and different tool methods. And so what we typically associate torque to is going to be a frictional force, and we take in this case, a screwdriver to a certain frictional force, and that screwdriver will then cam over, and it will then give us that torque value that we're looking to achieve. And so let's take a look at some of different manufacturers and how they handle spring compression. And in a lot of different drivers, spring compression is what gives us that frictional force to be able to give us our specific torque value. Now, you may see some other torque screwdrivers out there that may be considered a disposable type item, where they use a plastic clutch or some type of method that doesn't use a spring. But for most all torque screwdrivers are going to be using a spring that has a certain constant spring rate to it that will allow us to be able to generate the torque values that we're looking to achieve. And if we look at some of the other drivers that may be out on the market, you can see how they go about compressing the spring. And so a typical clutch mechanism may be these types that use either a ball bearing and some type of cam that will allow that ball bearing to compress the spring. So in this case, we have a series of 3 ball bearings that sit inside this race that will move from one lobe to the other here on this cam, causing the spring to be compressed. On this model here, we're looking at stationary ball bearings here that will compress the spring as they hop or press down over these rods that come across. And you can see the same thing kind of in this situation where the ball bearing is stationary and the arm basically pushes down on that to compress the spring. And then this system here is very similar to this one as well. So the way that we compress the spring is a little bit different than this. We use a radial cam design. And what that looks like is we have a 6-lobe cam that holds 3 ball bearings. And these ball bearings, as the handle is turned, will push in to the housing on a larger ball bearing that compresses the spring for us. And so we get a very smooth, a very consistent torque reading and very consistent compression of the spring that allows for not just a horizontal, a vertical compression of the screen, but the actual ball bearings will move in a horizontal direction or perpendicular to the housing of the spring. So we get a really good, consistent spring compression. So that is what you will see as the difference in the different types of tools. So you have manufacturers that will use different springs, obviously, and different cam mechanisms. And that's kind of the differentiator between those two or between different manufacturers of the screwdrivers. Now, when we're looking at cleanroom standards for a cleanroom type of rating, cleanroom, if you're in this webinar and you're looking for cleanroom information, you probably know all of this already. But again, cleanrooms have different ratings on how much particulates are allowed in 1 cubic feet of area. And so they can go from class 10 all the way to class 1000. And the way that we handle our cleanroom ratings, they are designed, or our tools are designed to be used in a class 100 environment. And that means that there is allowable 100 particulates in that cubic foot. And compared to, say, a normal office environment where you can have anywhere from 500,000 to 1 million particulates in that cubic foot, we're really drastically cleaning that air, where there is a constant turnover of what's happening as air is moving through there, removing any type of particulate that may be in there. And so those are kind of the clean room standards that we designed the tool around. There's not necessarily a category as it relates to tools for a particular class of clean room, but we have designed those to be used in a class 100 environment. So if we look at the clean room screwdrivers, they have a torque range that go from currently 1.6 inch-pounds up to 125 inch-pounds. And that's covered over 4 different models. Then 2 of those models use the same body type. But the outside of the tool itself is developed with a special coating for the powder coat on there. And we have special seals and special grease that is in there to help prevent any type of particulate to be generated. And then we also have a seal on that near the bit holder of the tool to make sure that we're not releasing any particulate out of the tool whatsoever. And so the accessories that come with this for the larger model are FG Cleanroom 125i. Does also include the T-bar handle for that, and we'll also show you what that looks like for the other version here during our demonstration process. So those are some of the highlights as it relates to the Cleanroom tool and how it's designed and why it's designed the way it is for that particular type of setting. Now, again, same as we talked about with the Cleanroom. If you're here and you are looking for information on ESD, you probably already know what that is. But if you don't, the ESD stands for electrostatic discharge. And I'm sure everyone in their lifetime has experienced this. If you walk across a carpeted floor and you go and you touch a door handle and you get a shock, that is what we are talking about. And that is basically the transfer of a negatively charged molecule that builds up, and then we touch another conductive surface, and a spark will shock us. And in this case, when we're dealing with electronics manufacturing, any type of static discharge that may be extremely low in voltage can also cause damage to the part that's being worked on. And so along with other steps that help to control ESD for the manufacturing process would include wrist straps for operators and ankle straps, all of those different types, the workbench, those can help all of this as a package with our ESD tool to help provide that no transmission of static electricity comes from the tool itself. And so that is basically what ESD is. We've developed our ESD tools to meet the IEC requirement, the ANSI requirement, and basically what that means is that there is a surface resistance of 10 to the 4 to 10 to the 11th ohms for that particular item in for this particular rating. And so our ESD screwdriver does have, again, the same range, 1.6 to 125 inch-pounds. Does have the high-grade dissipative coating, high performance wear and wear resistant internal seals, just like the Cleanroom driver does as well. This one, however, does not have the additional coverage for the seal that is on there, but this is what the ESD driver is, and it has the same cam mechanism that we talked about as well, but the big difference is going to be the coating for this tool. Now, this coating isn't a spray-on type of coating. This is actually built into the coating for the tool. So that coating is designed to last the life of the product, and it is not the spray type of ESD coating that can be used in certain situations. And so that's going to lead us basically to our demo portion for today. And what we're going to show you is the ESD version, our 125 tool, and we'll show you the different components that come with it and how the torque values can be changed on this tool. Now, this tool is a preset tool, so it is designed to be used at one torque value, but it does have a range anywhere from 25 to 125 inch-pounds. And how this is done to change the torque value, if you are going to be setting this tool possibly yourself, if this is going to be used in conjunction with a torque tester. The driver itself comes with the T-bar, and then this is the T-bar, and then this would be your adjustment tool for the actual driver. But how we get to this is we remove the end cap here on the tool. And inside the tool, there is a small set screw. Let's see if I can get the light in here so you can see it correctly. Right there. There it is. There is a set screw inside there. And then this set screw will allow us to go ahead and change the torque value. So I'll insert the key that comes with the tool. And basically we just need to turn it about 20 degrees or so just to remove that set screw from holding the adjustment mechanism. And then we pop in the key, and then we can turn the tool either up or down by just rotating the key here. So if we rotate it counterclockwise, that's going to be decreasing the torque. If we turn it clockwise, then that is going to be increasing the torque. And then we would put this onto a torque analyzer and check to make sure that the torque output is where we want it. And then after that, we can come in, we would reinsert the smaller key here to lock down the set screw. And we can then go ahead and put the cap back on. And then tighten that down. And then typically a calibration facility will put a sticker on the end here showing that the tool is calibrated to whatever value that is. And then maybe another asset tag or another calibration sticker would go on to the body of the tool. And so this is a look of the ESD tool. And then if we were to use the T-bar with that, we simply pop that on. And then this gives us the ability to have a little bit more leverage as we're using the tool, especially at the higher torque range for this particular tool. So that is going to conclude today's presentation. And so if you have any questions, feel free to type those into the chat. We'll go ahead and answer those if you have any. And so let's see if we have any of those. Chris, do we have any questions?
Hello, Dave. Yeah, we have a couple questions to start off with. One is, once a preset tool is calibrated, can the torque setting ever be changed at a future date?
Yeah, so basically that's kind of just what we had went through with the demonstration. Gives us that ability to take that preset tool, which is going to be used out on the line for the operator to go ahead and use that tool without having to worry about making sure that it is correctly set. We can then take that tool and use it in a different area if we want. We would come in, go ahead and make the torque adjustments as we showed in the demo. That will allow you to set the tool anywhere within the range of that particular tool. And so as we mentioned, we've got 4 different models that cover a range from 1.6 to 125 inch-pounds. So you have the ability to adjust that tool up or down throughout the range of that, but it is designed to be a preset tool working out on the line, so the operator just grabs a tool and use it, and they don't need to worry about any other settings on it for that.
All right, Dave, thanks. Another question we had is, when you're calibrating a tool, is there a recommendation of number like test data readings to use when calibrating a tool?
So a typical calibration goes something like this, where you'll take a tool, you'll bring it in to the lab, or if you're testing out on the floor, you take the tool and then you will exercise it for 5 to 10 readings. Then you will go ahead and take your readings in, and at that point to see exactly where the tool is. And that is going to be typically 5 readings for the calibration of of a particular tool. Most calibration facilities will follow that type of protocol, but you could have it any way that you would like if you're doing it in-house, obviously. But that is typically how it is, where you exercise the tool 5 to 10 times, then you'll take 5 readings to see where the tool is. If there needs to be adjustments made to the tool, then you can go ahead and make those adjustments and then kind of repeat that to make sure that the tool is producing accurate and repeatable readings for you.
All right, Dave. Another question we had is, do you offer adjustable version of the clean room screwdrivers?
The Cleanroom adjustable screwdriver is coming. That will be here. I'm not exactly sure as the release date comes, but that is part of the roadmap for an adjustable tool to be available in those versions.
All right, Dave. That's all the questions you had for today.
All right. Thank you very much for joining us today. I hope you got some information regarding Cleanroom and ESD tools that are going to be able to help you in your application and your processes. So thank you very much for joining us, and we look forward to seeing you again next month at our next webinar. Thank you so much, and we'll talk to you soon.